Hi everybody, Bob Giglio again for another video. This time we're going to be talking about my router table and the fact that I want to upgrade it. So this is my next project on my list, and while this router table has given me many years of very good service, about 25 years, I find that there are some things that I'd like to upgrade on it and make it even easier and more versatile for me to use. So I'm going to have this video just cover the what's good about this table, what's not so good, and how we're going to make it better. So the good features is that it is mobile. That is the number one benefit of this. I think the biggest benefit is I can wheel it around my shop, depending on the work size or the pieces I'm dealing with, and move it around to make sure I have enough room to do the job. The other nice, very important thing I have here is a safety start-stop switch, which I added about a year ago, which is very important for safety aspects on wanting to shut it off quickly. So that's the good part. Also, it has some nice storage here. Here in the, I don't really use this compartment here for storage because it just generates a lot of dust. So that's something that we're going to upgrade. We're gonna separate the chamber where the router is and add some more storage on either side. I also have two nice drawers down here that I keep my router bits and jigs and stuff, fixtures, and I also have another drawer where I have some routers, my handheld routers stored. So we can make better use out of the storage for sure. So that's one of the upgrades I want to do with this project. But more on a functional basis, some of the things that really been bugging me lately is this fence. This fence here I have used for many years, and it's a pretty well built one. It's a triangle of aluminum, very good sturdy aluminum. It has a nice dust port on it. It has these movable, adjustable split fence over here made out of MDF. But the worst thing about this fence is these under here. The clamps on these use just basically a T-bolt setup with this hold down clamp, and it does not hold. I mean, I've cranked this thing down so hard, and still this fence will move on me, especially when I'm using bigger pieces and I'm applying force against the fence with either featherboard or my own pushing of the material through the router bit. It's really been aggravating for me, so I have to double clamp it with another clamp here behind it. So it's just something that's really been bugging me. The other thing is these collars, these rings that you change out depending on the size of the router bit you're using, and it's a real pain for me because these 4 screws have to get undone. They fall down into the compartment. I use these little O-rings here to kind of keep them in place, but they slip off all the time. So that's another problem area that is a big aggravation for me. And then probably the biggest aggravation for me right now is setting the height of the router bit. So, and that's where I have to go under this table, and I got to reach around and crank in the back here the actual height adjustment knob on this plunge router that I basically fitted to this plate under there. The router plate. So, I mean, it's a very powerful router. It's variable speed. I like the router, and I could use it in the table or handheld, but it is such a pain to turn this knob back here. You can barely see it. To get the router bit height to change, especially when I'm changing blades. I'm always working under here. Not a good, comfortable situation. So, but I do like the fact that it has a speed controller right here. It's a variable speed motor, so I like getting access to it and knowing where my speed is based on the number. So that's a good thing. But I really got to improve the depth adjustment, make it easier. And what most woodworkers do with this type of setup is they'll actually put a router lift in and have this plate be part of a system where it has a crank to it, and basically there'll be a lift mechanism that lifts the motor up and down as you turn the crank. And I've looked into those, and for me to do it with that approach, I'd have to basically replace the router, which I like. and then replace this plate with a new plate and a lift system. And I'm looking at probably $800 to $1,000. And I'm like, I just don't see the need for that, because I like this router. The table plate is fine, other than I can't raise it. So what I'm going to try to do is, since this is a plunge router, it is designed to be moved up and down with this fine adjustment knob here. And I'm going to figure out how to do this from the top of the table, maybe through the strut from the top. So that's going to be my first project that we're going to attempt on an upgrade here, is how to make this adjustable from the top of the table. So I pulled the rod out of the table and I removed the 3 screws, the mounting screws that mount the top plate to the router. So I'm going to remove the top plate, and just to show you now, this adjustment knob here, down here, is right here. So it can do very fine adjustments. As you can see, the scale goes down to 64ths of an inch. So it is something that we want to figure out how to access from the bottom side of the router, or the foot of the router. And if you look in here, maybe I can get you some light on this. If you look in here, you can actually see the rod. And that's a long threaded rod that looks like it has a guide bushing on it that it threads into, and allows the movement of the frame to go up and down with that guide bushing, and locks it into that given position that you're in. So what we're going to try to do now is somehow, this is very good, because if we can figure out how to get that end of the rod to connect to that in a way with a tool, and then I could actually crank it from the bottom. I did a little research and pulled the owner's manual out of my files. I also went online, and I learned that for this particular model, which is the Porter Cable 7529 plunge router, it's about a 2 horsepower machine. It pulls about 12 amps, which is fine for me. That's really all I need. I learned that they used to offer a kit that would be a retrofit kit to do exactly what we want to do, allow or provide hardware that would allow us to connect to that rod, and allow some sort of shaft or crank handle to come out to the bottom of the shoe, so you can access it from the top of the table, the router table. So what we're going to do, since we can't get any information on that kit, we're going to go ahead and take this router apart and see what that rod, what the thread size is, or how we can connect to it, and then go from there. So I'm going to basically just take off these 4 screws, see if I can get this bottom off. I've checked online for videos how to take this particular router apart. There's nothing available. So my intuition after looking this thing over says if I could just take this lower housing off, hopefully the motor won't fall apart. But before I do that, it's always important to take off the brushes, because if the armature comes out with this housing, then the brushes are going to pop in there, and to avoid the hassle of all that happening, I'm going to just go ahead and take the brushes out right now. Let's see, there's one. Set this out here. One. Right here. Okay, those removed. Let's see. Let this come off. All right, so it is starting to open up now. There we go. So it looks like it is separating. Let's see how we're doing here. Okay, it looks like you need to disengage this top knob, which is holding off this adjustment knob, like so. That looks like it's been holding the casing, the housing from coming off. So go ahead and just put these over here. Okay, and there we go. Okay, so success. We got the housing motor off, And it looks like the armature came with us, so that's fine. We get a little sawdust here and there. We need to clean that up. Bring on it. And this is the rod right here. So now there's a couple of more washers here we got to be careful with. So and then we have this spring. So let's see. This goes first. Then we have this retaining clip. So it looks like if we unscrew this rod, this is the height adjustment mechanism. Let's back it out all the way. There you go. So we have this retaining spring retainer on the bottom. So just put that aside. Okay. And here's the rod. So as you can see, it's just a threaded rod. And you turn it with that knob on the top. And so if we can connect this to this threaded rod, then I think we'll be in business. So let's figure out what thread this is, and then we'll figure out if we can get some sort of coupling nut, or maybe even grind this end down so that we can attach a tool to it. So I determined the rod thread is a 3/8/16 American thread, SEA thread. So and so I went to the hardware store. I picked up this coupling. It's a 3/8/16 threaded coupling. It's used for like turnbuckles or coupling two threads together like we're doing here. So I could do that, and then now I have a thread on the inside. Now I could either put a set screw in there, so I get a hex head to turn it, or maybe I can come over this with a socket from the inside of the tube. But unfortunately, the tube itself, if you look into the tube, do it this way, the tube itself is not large enough to accept this. So I also thought of another option where I found this threaded insert here with a 3/8/16 on the inside. This insert, you see me use this in my other projects. This is designed to go into wood. You basically drill this into wood, or you screw it into the wood, and then it becomes a mechanical thread for fasteners. If you want to take like legs off a table or something like that. But in this case, it's going to work out nicely because that's a hex fitting right there. So all I needed to do is get like a hex wrench. And it turns out to be a 10 millimeter hex. So look at that. I can actually now get a crank or a tool like a hex wrench into the top and then turn it from the top of the table, as long as we drill through the plate and so forth. So that's a good option. I like that option. And the other thing nice about this option is once we have it set up, it's gonna basically go into this opening like this, okay, and it fits in nicely. So there's our way to attach our tool to it. So the only other concern I have is, well, I don't want any dust or sawdust getting down inside of this shaft where the adjustment nut's going to be. I don't want to get this all dirty and contaminated and fouled up. So I'm thinking of either putting an O-ring around the base of it, or using what we use in plumbing a lot is just a tube seal like this for a flange fitting, and I could put this on. So a couple things I'm going to do is I'm going to check the height, see if this is going to be, if I should cut this. And then the other thing I can do is I could actually drill a set screw into this so that this won't actually unscrew from the shaft once we have it installed. And that's one of my concerns is once we thread this on, I don't want to have a situation where this unthreads on me when I'm using the router and the table, and now I've lost my connection. So one way to do that is to drill basically a set screw into this and use a set screw to hold it tight. Or I could use Loctite, or maybe both. to have a robust design. Okay, I pulled out the shaft, the adjustment shaft from the router, and here is the collar nut that actually runs up and down the shaft to adjust the height of the router depth. And so this is that insert, that 3/8 insert we talked about. It's used for wood. And what I did was I threaded it onto the end here. I had to run a die over the end because this thread turned out to be more a high tolerance thread, which means the shaft's a little bit larger than 3/8. The thread pitch is 16, but the shaft diameter is a little bit bigger, about 0.008 of an inch bigger. So I had to run a die over the bottom of this for a normal size 3/8/16 nut, or in this case an insert, so it would fit on easily. So now that I've done that, I then cut this thread insert to about a half, a little bit less than, a little bit more than half. So I still get the hex fitting here, but now I have a good, I would say 1/2 inch of thread that is now connected to the shaft. So what I'm going to do now is I'm just going to put this on my drill press and run it and just smooth out any irregularities with the outside circumference, because you're never going to get this perfect, and we'll make it smooth so it runs up and down the shaft smooth. Okay, that's better. It's not perfect, of course. I'm improvising here. I don't have a metal lathe, so I use my drill press to make this more concentric, and it filed it down so that it is more concentric, and I think that's an improvement. And now let's go ahead and put those O-rings or washer on this so it rides up and down the shaft, the bore in that strut of the router smoothly. And there it is. So I smooth this edge, and I think that's a good job. So we set up the shaft with the new insert at the end of it, and I marked a spot for the set screws. I'm going to drill a set screw through the shaft, through the collar, and then into the shaft. And here's a set screw. Here is an 8/32 set screw, so I need to go about 3/8 inch deep. So we're going to go ahead and set the gauge on that on the drill, and we're going to drill this and then tap it. Now I'm going to go ahead and just tap the hole. This is going to ensure that we can lock this collar onto the shaft and don't have to worry about unthreading. So here is the end with the adapter on it, as you can see. Nice hex there. And I decided to go with the O-rings. They fit much better than that one big tubing washer. I filed some of the grooves down to even them out, and I actually filed them to open up an area so the O-ring can cross over, as you see here. And there's my set screw right there. So it's pretty well secure. I think it came out pretty good. And that's going to be my access to raising and lowering the router from the top of the table. Okay, let's go back and install everything and put it back into the plate, which we're going to have to drill. So I'm going to spray a little dry lube into the tube, because this is where the O-ring is going to slide up and down. I want it to be nice and smooth. I also sprayed a little bit on the O-rings themselves. So we don't want any dust to collect in there. So I'm going to put the shaft through with the hole in it, with the drilled hole in the bottom, like so. We're going to thread on our new coupling, which is going to be, I'm going to put a little bit of Loctite on it, just extra protection, so this will never come off. Just put a couple of drops on the threads. That should be good. Okay. And then we're just going to thread on this coupling. Now we're going to line up our hole that we put into the shaft. I'm going to take our set screw. I'm just going to put a little bit of Loctite on that so it doesn't come out either. Should be good. Go ahead and screw that in place. A little squeeze. Okay. And then we're just going to feed this through like that. See if it turns. Okay. Yeah, it turns. Good. And what's nice about those O-rings is it'll keep the dust up, but it'll also keep the hex centered in the bore of the strut. So that's good. And we're going to turn over the housing like this. There we go. And then we're going to reassemble the shaft. Okay, with this in now, there's a retaining clip here. I'm just going to make sure it's in okay. Okay, and now this should allow me to raise up. It does. Up and down. There we go. So this, now that's how it moves. Very good. I'll just put a little more lube in there. Okay. And now we're going to reverse the disassembly process, and we're going to put in make sure the armature turns, no problem, nice and smooth. Okay, now we're going to put back the brushes. This is the front one. Put that in like so. And they do kind of, these are a little tricky to put in because there's a spring that you're working against, and that keeps the brushes held against the commutator on the armature shaft. The only trick is you got to get it down so that they don't, this cap has to go on without it popping out of the little retainer that fits into it. Okay, and we'll just screw this down like so. Now we're going to flip it over on top. I'm going to put back the knob now, right here. There's the knob now, adjustment knob. So the paper washer goes on first, then the steel washer, then the spring washer, and then goes the knob. All right. Now, let's see if our little modification works. We're going to just use our 10 millimeter hex. You see, I'm screwing it now counterclockwise, and the knob is spinning down here, just as if I was turning it from the top bottom. So this is what I wanted, and you see now it's adjusting the height of the router base. So this is going to be a big improvement for changing bits on my, when it's installed on my table. To drill a hole in the plate, the first thing I'm going to try to do is precisely locate where the center point is of this shaft here of the strut, where we put our hex fitting in. So what I'm going to do is I'm going to screw it back out counterclockwise, the adjustment, until the actual hex fitting comes to the surface of the plate, which is right there. You can see it right there. So what I'm going to do is, I happen to have these little pins, center points that you use for dialing. When you dial, you use them to locate the center point of the dial on the other material. So I'm going to use them. I'm going to put this here, and I'm going to put a plate on. Okay, and I'm going to line up the screw holes that I usually attach the plate with, like so. I'm going to put the screws in, the mounting screws for the plate. Like so. And just tighten them down. And this, once I get it in the correct center point for all the screws, then this is going to allow me to actually score the underside of the plate with that center point, and basically put an indentation into it, so I know precisely where the center line is, center point is for my hole that I'm going to drill. So I'm just going to go ahead and do that, tighten them down, not too tight, and then I'm just going to take a mallet, give it a couple of whacks, make an indentation, and then take off the screws. Take out the screws. And that should center punch the plate for me. Let's see if it worked. And there it is. There's a center punch. So that's pretty good. So now we're going to go ahead and drill this hole. Okay, so I'm going to drill a 5/8 hole, which is a little bit bigger than the diameter of the hex screw, and drill it with my Forstner bit. Okay, let's mount the plate back, and we're all set. We're all done. Let's see how things turn out. Now I'm going to get a speed handle for this, but look at that. Up and down, just like we talked about. That is sweet. I just saved myself about $1,000 by doing that. And I get to keep the router I liked in the first place. So that is a nice system. Just gonna get a crank. So to improve the crank handle, instead of using this one, which I could use easily with this, but it won't give me a very fast cranking with this. It'll take me some time. So what I did was I went on, I found this crank handle on Amazon. I think it was only like 14 bucks. And I figured out that if I could get a Allen wrench like this one, 10 millimeter Allen wrench, to attach to this handle, then I'd be in business. So one of the things I came up with was I'm going to take this handle and figure out a way to attach it to this Allen. And what I came up with was I got a 10 millimeter 1/4 inch drive socket, just a regular automotive socket, and it just so happens to be fit right into the bore of this handle. And there's a little set screw here, so I can tighten the set screw like that. And now I have that 10 millimeter socket fits nicely in the handle. I locked it in with the Allen wrench, and now I can just put this right in here, just like that. But to keep that from falling out, I'm going to use a very strong magnet. Sorry, I'll just put in the base of the socket like that. And now, when I do that, it is now my crank handle. So all I need to do now is take this Allen wrench and cut off the end of it and smooth it out, and I think we're going to be in business. So this is a tool steel alloy here for the Allen wrench. So we're going to try to cut it with a hacksaw and see if we can make any headway, and if not, we're going to change our approach. So let's try cutting it. See if I can get this to be started. Okay, that's pretty hard. So like I was expecting, it would take a long time for us to hacksaw through that. So let's try a grinder, a grinder with a steel cutting disc. Okay, with the 10 millimeter Allen cut, long Allen cut, I can show it to you here. I cut it as you saw and grinded it and smoothed it off. So that should be very nice for what we want to do. And we're just going to put on a magnet on the top of it to hold it within the socket like we talked about. And we're going to just put this in here like this, like that. So that's pretty secure. Again, I'm securing the socket to the handle with this set screw here, 10 millimeter Allen. And then I'm going to slide this piece of PEX over it just to give it like a bushing so that when I crank it, it doesn't wobble in this hole. So this happens to be the right size OD for the PEX. And now, as you can see, I can simply insert it into the opening there and I can crank it up and down. Let me give you a better view of that. So you can see I can crank it down, the router motor goes down, and then back up again with one hand, and just do exactly what a rotor lift table would do. So it's really is a good solution for me. I can use my Porter Cable Router that I liked very much, and I can preserve it, and now I can have it adjustable from the top. And maybe this will help you. It certainly saved me a lot of money. And now to go on this next phase of this router table upgrade. Thanks for watching.